Hi, this is Jeff Evans from Evans Performance Academy. We're going to be taking a look at some basics with our PC Link software so you can get started with your Link G5 or G4X system. Without further wait, let's jump in to check this out. Okay, so let's get started. We're going to be taking a look at how to set up a switched input as well as a trim pot input for our Link G5 and G4X programming. Now, the switched inputs can be used for a variety of different things within runtime values or to turn something off or on within our link. So an example of using a basic on-off toggle switch input to our link would be if you want to have a low and high boost setting, you have a switched input that you can wire in, configure it properly, and then when you turn the switch on, you'll get high boost, turn the switch off, you'll get low boost. So that's just one example of many, many things we can accomplish with a switched input. Now we also have the ability to set up a trim pot. A trim pot is a little bit different than a switch because it's actually going to be using an analog input, and the trim pot will be a 0 to 5 volt range or scale, and each click position of the trim pot sends a different voltage input to the link, and that voltage input is associated to that switch position. So for example, I'm going to be showing you how to set up an AEM 12 position trim pot. Each click position will be associated to a certain voltage value. We can utilize a trim pot to give the driver a multi-selection option in the operation of the vehicle. So for example, you could have drive-by-wire. You could have multiple drive-by-wire tables based on clicking through that trim pot, different positions. For a boost control, you could have multiple different boost targets when you're going in and you're operating your vehicle. And let's say driver wants more power, it can simply click that trim pot and allow more and more boost to be to request it and to be ran within the boost control routine. If you're talking about traction control, we can use a trim pot to vary the amount of allowable slip between our driven and undriven wheels. So the trim pot is a really handy tool for a driver, giving them a huge ability to vary something like boost or traction control slip on the fly. We don't have to hook up a laptop and do any programming changes. It can all be accounted for within each click position. So both of these are really powerful, and we definitely want to know how to set them up here in the software. Let's first jump in and take a look at the most basic setup and configuration here. That's going to be working with a switched input, turning something on or off. What we're going to do right now is move from our basics page, and we're going to jump over here to our digital input page. Digital inputs represent something that's either going to be an on or an off status. It could also be a pulsed status. So for example, with an ethanol content sensor, that's a certain amount of pulses that happen over a lapsed period of time known as frequency. So this would be one example. Another example would be an oil pressure switch. Oil pressure switches are either going to be an on or an off status based on an oil pressure threshold. If we're below a certain oil pressure, the switch is on. If we're above that oil pressure, the switch is off. So these both represent two different types of digital inputs, but the idea of a digital input should make sense. It's going to either be able to count an on or an off state from the particular thing that we're trying to wire into a digital input. In the case of a basic on-off toggle switch, this is exactly what we're going to use a digital input for. What we're going to find here, in order to set up and work with an on-off toggle switch, we will be using a general purpose input. Now, the reason why we're not using another defined parameter in here, because these are used for a specific task or a function, and when we're looking at the runtime value or the value associated to setting up this channel, for example here, power steering switch, we'd be able to log that in our parameters and it would show power steering switch either on or off. If we're setting this for, let's say, boost control, obviously we don't want to use power steering switch. That's why we have to use a general purpose input. It allows us a lot of flexibility of what we want to use this for, and we can actually call that out here and label it. What I'm going to do here in the labeling is actually call this high boost switch, and I give that a custom name, and we can see now general purpose 1 is associated to our high boost switch. Now the source, this is going to be where we've wired our switch into for the link. When we're talking about a basic on-off toggle switch, or even a momentary button that we'll be pressing and releasing that can also have the same type of functionality, a pulsed input to the link, we'll find that we have to go in and know first where we've wired one leg of that switch into the link, which specific digital input, in my case it'll be digital input 3, and then the other leg of the switch, are we sending a 12 volt into the link, or are we grounding the pin, so we're going in wiring the other leg of our basic switch or basic momentary button to a chassis ground. In my case, I prefer to always use a chassis ground whenever possible. So just keeps things a little bit more simplistic. However, you can use 12 volt or ground when we're setting up a switch. How we configure them will be different. I'm going to go through how to set this up, whether it's a ground input or a 12 volt input through your switch. In my case, I have one leg of my on-off toggle switch going to chassis ground, and then the other leg is going into the digital input 3. So when the switch isn't turned on, it's in the off state, we should find that the pin isn't grounded. And then when I do turn the switch on, it's going to create a ground path right to the digital 3 input pin, and the link should be able to count that as an active state. Let's go through and setting this up. It's very, very simple. Under the source, we're going to go ahead and define this as digital 3 and click OK. The next thing we can see as soon as I go and set it here, in my window down here below on my runtime values, I can see digital 3 high boost switch. We see that it's inactive right now. Now, if I go ahead and I go and turn on my switch, I'm going to turn it on right now, we're going to find that the status does not change. It's still showing inactive. I turn the switch off, nothing happens. That's because the next few parameters aren't defined properly, and it's important that we make sure that we're setting these up correctly so this state switches from inactive to active when we toggle it on, and from active to inactive when we toggle the switch off. So we'll find the pull-up resistor in active state. Both of these need to be set correctly, whether we're sending in a ground to ground the pin from the switch, or we're sending 12 volt into the pin. In my case, when I'm dealing with sending a ground into the link, so I'm grounding the pin when I'm turning the switch on, I want to set the activation state to low, and then, more importantly, the pull-up resistor here should be set to on. Now when we do this, my switch is in the off state. So it's off right now. We should see that the status here is showing inactive. Now, when I go in and I toggle the switch on, it's showing active. When I turn the switch off, it shows inactive. So now the switch has been configured correctly within our software. Now, let me go through another option here that's very important to understand. That's going to be our input latching feature. If you have a momentary button, so not an on-off toggle switch, but a momentary button, still there's going to be two wires that you deal with. One wire, chassis or 12 volt, the other wire comes into the digital input that you've configured here and you set up in the software. If we have a momentary button, and if I go in and I just push the momentary button, let it go, you can see the state goes from inactive to active, but that may not be ideal. You may want to push that momentary button and have it latch on, and then push the button again to turn it off. That's what the latching function represents here. So right now, taking a look, I'm going to push, and I just switched real quickly as I'm talking right now. I have a quick disconnect. I've switched the switch type from an on-off toggle to a momentary button. Now, if I push the momentary button, notice that if I push it and let it go, it goes again inactive, active, inactive again. It's not latching on. If I turn the latch feature from off to on, now if I simply go in here and I push the button on the momentary switch, notice that it's showing active. Now I've let go of the button already. It's showing active. If I push the momentary button again, it goes inactive. And that's what the latching function here represents. It allows you to turn on a momentary style button into a latching function that you would have with an on-off toggle switch. It allows you to convert things virtually here, which is nice if you want to be able to have that kind of functionality and not have to add a different switch and change up some of the things in your vehicle. So just keep that in mind in terms of how to set up an input latch and what that represents. Let's go ahead and just turn that feature off. And now I'm going to switch back over with my plug and play connector to the on-off toggle switch, just to talk about the next bit here for the pull-up resistor and activation state. So the way we've set this up, this is assuming that we're grounding the pin digital 3 on the link, and that's allowing my switching function to work properly because I've set it up to essentially pull the ground or ground that pin. If I set a 12 volt in, so I've wired one leg of my switch into a 12 volt source, the other leg of the switch going into digital 3, when I turn my switch on, I'll be sending 12 volt to that particular pin. In this situation, we need to change our pull-up resistor and activation state. We want to go here and change the pull-up resistor off, and the activation state would be a high activation. Now notice it's going back here to inactive. I actually don't have my switch wired this way. And if I turn the switch on and turn the switch off, notice there's no activation state change. That's because it's not set correctly here for the input type and how I've wired my particular switch. So those details are important that we need to pay attention to. But setting up a switching function is extremely simple here. And again, we use this general purpose input to accomplish that task. So now if I'm going to do boost control and I want to have a switching function happen, I can simply go in and point this to this general purpose high boost switch option, and allows me to turn a boost target from low boost to high boost. If we jump in here, we can just look at closed loop boost, for example. Everything is off in here. We would actually set that condition here to use that switching function. So it would go from boost target 1 table to boost target 2 table. We'll get into boost control later, but just understand that's how we could accomplish that switching function with a switch. Okay, the next thing we're going to take a look at, or the last thing we're going to take a look at here, is using a trim pot. Again, the trim pot is something that's going to have multiple different click positions. Each click position is going to send out a different amount of voltage. The total voltage range for our trim pot will be 0 to 5 volt. So in my case, I'm setting up an AEM 12 position trim pot. Each click position will change the voltage coming into the link between 0 and 5 volt. We need to go and set up the scale, so we need to set up the click position to voltage scale, so the link recognizes each click position from 0, in this case, to 11. There's a total of 12 positions, but we're starting at the number 0, so 0 to 11 positions. And we can use that to vary things like launch control, boost targets, boost control, traction control. The possibilities are endless with a trim pot, but we need to go and set this up first. So let's jump in here to the analog inputs. What we're going to do here in this case is go down here, and I have one window already open, general purpose rotary switch. So this is a trim pot. Now, depending on what specific trim pot you're working with, it may be 6 click positions, it might be 10 click positions. In my case, with the AEM, it's 12 total click positions on the trim pot. In this case, we need to go and define real quickly those total number of positions. I'm going to go and define this as 12. Again, depending on how many positions your switch has, put that value right here. The labeling, I'm going to call this AEM trim pot, or if I'm using this for a specific task, maybe I'm using this for traction control. We can say TC trim pot, so give it some kind of a unique name, and we know now that general purpose rotary switch 1 is assigned to the TC trim pot. The next thing we need to do is go in and assign the analog input that we're configuring for the actual trim pot. So the way the trim pot's going to work, there's 3 wires. One wire is going to sensor ground on the link. The other wire is going to our 5 volt power reference that powers all the 5 volt sensors on the actual harness. And then the last wire is our signal out from the trim pot. And that's what we need to go in and configure for an analog voltage input. In this case, I'm going to go here to source, and we see that we have AN volts that we can choose. I've set it up here for AN volt 4 for my trim pot. If I click OK here, we're now going to find that we have a couple additional things to go in and configure. Let me go and do Control S, and let's store this real quick. Now, what we're going to see here, if we're taking a look at our window, we have a low and a high error. We also have minimum and maximum voltage, again, and the total number of positions. Going down here, there's a minimum position and then an error value. The minimum position, in my case, I could start at 1 if I wanted to go in and designate that. So when the switch is all the way to the left, so the first click position, I'm going to note that as position 1. Then I need to set my voltage scale. What's the minimum voltage? What's the maximum voltage for my trim pot? You should be able to find this from the data sheet. If you're unsure of what the minimum and maximum voltage is going to be for your trim pot, once you've configured your settings in here, you can go into tuning, into runtime values, into your analog window, and note your specific analog voltage input that your trim pot has been assigned to. Right now, my trim pot is in the first click position. If I go in here and turn it to the next click position, we can see that it's going to be 0.45 volts. The second position, 0.9, the third, fourth, fifth, sixth, all the way up there to a total of 12 positions. So we could actually know what our minimum voltage is going to be. That's the first click position. And if I go all the way to the end, we're at 4.96. So technically speaking, that's the highest voltage that's coming out of this, but we would note that as 5 volt. So that's my total voltage range. Again, if you didn't know your minimum maximum voltage, you didn't have anything noted on a data sheet that you got with a trim pot. So that's going to be how I know that total range, again, without having the information supplied for that specific trim pot. Now there's an error value that's going to be associated if we get above or below our error, low and high. In this case, we know that it's going to be between 0 and 5 volt. That's the total range of the trim pot. So we lose the functionality of the trim pot faulting out, meaning if 0 is the minimum, we have to set the low detection at 0 volt. And if essentially 5 volts the high, we have to set the error high. If we go above the volt, or we can't go below 0 volt, but if we were able to go, let's say, below 0 volt, it would be able to detect that. But in this case, the circuit's 0 to 5 volt. So that's not going to change. And we need to go in and leave the scaling here 0 to 5 volt and then the error value at 0, because our total range is 0 to 5 volts. So we can't get any more specific with this. We have to essentially disable the error detection function, and that's how we do that right there. Now, the next thing is to actually test this and make sure it works properly. In our runtime value window right here, you're going to see as soon as you populate and set up your general purpose rotary switch, that over here you can actually see the status of the switch, so how it's counting through the different click positions. Let's make sure that it's actually counting all of the positions from essentially the first position to the 12th position. So in this case, there's the first position that's off, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and finally 12th. So it is counting all of our trim pot positions. Very important. We don't want it skipping over, let's just say for whatever reason, skipping over a particular position as it's counting up through the different voltage sweep in the voltage range from the trim pot. As long as we've assigned it properly here, everything should function perfectly fine when we're looking at our trim pot status here. So now we could go into something like traction control or boost control and assign the trim pot click positions to have a task, such as varying the amount of percentage slip in traction control, or going into boost control and varying that boost target based on a trim pot click position. Pretty handy calibrating and tuning tool, especially for a driver's aid. It gives the driver the ability to have variations and different parameters, different conditions. And for example, if you're racing in a raining condition versus a dry condition, you're going to be definitely wanting to vary that amount of allowable slip in traction control. So it gives the driver the ability to do that on the fly without having to hook a laptop up and go have to find a tuner to make those changes if he's not comfortable with that. It gives him the ability to do all of that right from that particular trim pot, the switch that he can actually interface with in the cockpit. All right, so that's going to be it. Taking a look at setting up both a switch function and a trim pot function. Very easy to set up, very powerful in terms of what we can accomplish and the functionality with either type of input and switching type function, and something you're probably gonna likely use in setting up your vehicle. Thanks for watching our tutorial. If you're interested in learning more about how to tune your Link G5 or G4X system, check out the video description below where you can find links to our school, some promo codes to get you started and save some money. If you're interested in learning more about Link engine management products, also check out the video description below. That's going to wrap it up here. I hope to see you guys in our school.